It's a pleasure to be with you today and provide this overview of Exact 3236, ExxonMobil's newest commercial polyethylene plastomer. I'm Tom Miller, a launch manager in our polyethylene marketing organization, and I'm joined by Mariana Smits, an application development engineer in our European technology organization. We're both excited to be with you today talking about this product and expect to take about 25 minutes to share 14 slides worth of information with you. So let's get started. Briefly, Mariana and I will be covering the market, our new product offering, details supporting our claims of differentiated performance, and our hopes that this content helps spark new collaborations as a result of our time together today. Plastomers are a key enabler for the flexible packaging market, and there are a broad macroeconomic set of trends that are driving high demand for packaged products. Certainly a growing middle class accustomed to flexible packaging that is convenient and personalized, meaning just right for their individual lifestyle, is ever present. Grab-and-go meals, a snack-based lifestyle, and the significant surge in purchase of staple and shelf-stable foods driven by the sad pandemic have only added to this demand, as has the jump in consumer products and meals delivered through e-commerce channels. Now, polyethylene plastomers exhibit several differentiated attributes that endear them to packaging designers. These include low seal initiation temperature and high hot pack strength, which enables faster filling and closure of goods that are packaged on form, fill, and seal equipment. Pair this with the high toughness, high flex crack resistance, and the lock-up sealing characteristics to ensure hermeticity, and it is no surprise that designers turn to low-density plastomers for premium packaging requiring the highest performance. So much so that the flexible film market for polyethylene plastomers was approximately 410 KT in 2019 and has grown to about 460 KT this year, owing to an average 6% annual growth rate. And you can see that North America is a significant market with near average growth. To put it simply, Exact 3236 was designed to deliver the stiffness and toughness benefits of a 908 density resin and the sealing characteristics of a 902 density resin. Now we offer a sister grade, Exact 3237, which is the same base resin to which we simply add a slip and anti-block package. Now, these are both linear ethylene hexene copolymers, and the hexene imparts significant toughness. Also, both are 2-melt index products to ensure low melt viscosity and fast, easy flow to enhance the caulking and seal-through contamination characteristics. The overall result is that these resins exhibit a broad range of utility, meaning a level of performance that I'm showing by this shaded cone in the graphic. To put it another way, the 908 density should not be misconstrued as limiting these products to the high-density plastomer space. Quite the opposite, we designed them for the heart of the high-performance plastomer market, where competitive 902 density, 1 and 1 point something melt index solution ethylene octene offerings exist. Such products are represented by the yellow dot at 902 density and 1 MI. And this product is what we used as a competitive reference throughout this presentation. And I suspect that the remaining slides will convince you that the sealing performance is indeed comparable to that of these competitive grades, and that there are stiffness, toughness, processing, and coefficient of friction advantages that differentiate the Exact 3236 and Exact 3237 from the pack. We will share that data with you after one more introductory slide. High-performance sealants are used to deliver faster packaging line speeds, stronger seals, and add to package strength to help them survive transport and handling to your store shelves. In particular, Low seal initiation temperature and high hot tack are critical for ensuring high-speed package line operation. Now, the increased use of fitments, such as spouts, flip tops, handles, and resealable mechanisms, all increase the demand for low viscosity resin flow around these molded inclusions. The 2-melt index of the exact 3236 and exact 3237 result in lower zero shear viscosity, which helps promote better flow than competitive 1-melt index grades with long chain branching. And the trend to all polyethylene packaging has driven film converters and pouch makers to blends that contain higher loadings of premium Plastomer sealants in order to increase the temperature differential between the outer high-density based print web that is in contact with the sealing bars and the inner sealant web where melting, diffusion, and bonding is occurring where the films are pressed together during sealing. So, in addition to any mixed material laminates such as polyesters, BOPP, other materials, or even in simple coex structures, I believe that the introduction of the exact 3236 with its 902-like sealing, higher stiffness, and higher toughness is ideally suited for all polyethylene laminates, those which are commonly mechanically recycled. Let's start by digging into the performance data. I'm showing you the hot tack curves on the left and seal force or seal strength curves on the right for a 1 mil or 25 micron monolayer blown film of the exact 3236, the solid dark blue lines, and the competitive ethylene octene based 902 density 1 melt index product as the dashed gray lines. Now these curves show you how the pull apart, let's call it short seal time tack, and then also the longer dwell seal force both increase as the seal bar temperature increases and more heat transfers into the innermost surfaces that are in contact with one another. In the case of the hot tack, the exact 3236 exhibits a lower onset temperature than the competitive 902 density grade with a nice, high, and broad hot tack plateau. Similarly, the onset of the seal strength curve tracks right atop the competitive grade with a slightly lower plateau value. Now, some of you may suppose that this is the result of the molecular weight difference, which is fair, but this is monolayer data and the overwhelming majority of other sealing data, including that of non-laminated and laminated coex films that Mariana will be presenting next, do not reflect that difference. The key message on this slide is that the two grades are largely comparable. Now, Mariana will take you through the rest of our data, and I'll join you again at the end.
Here we show the heat seal force graphs of co-extruded non-laminated films with a 1-to-1 layer distribution and in the sealant skin different blends containing Plastomer. The sealant skin was containing either a pure Plastomer, a 60% Plastomer or a 30% Plastomer blended with Exceed 1018, as you can see on the bottom right. On the left graph, the data of 100% Plastomer in the sealant skin are combined. In the middle graph, that shows the 60% Plastomer in the sealant skin data, and the right graph are the two films which had 30% Plastomer in the sealant skin. The x-axis is giving the seal bar temperature and the y-axis is the seal force obtained. The more the curve is to the left, the lower temperature is required to obtain the seal force. The different grades that are compared are exact 3236 with a dark blue solid line, the 902 density Plastomer reference in the dark gray dashed line, and we also plotted a 908 density Plastomer reference in light gray with smaller dashed lines. You can clearly see that exact 3236 has a similar heat seal force than the C8 Plastomer reference with 902 density when using the same percentage in the sealant skin. And it has significantly better behavior than the 908 density Plastomer reference. The red curve of Exceed 1018 is also included to show the order of magnitude of improvement that plastomers can bring. What I shared before were non-laminated films. On this page, we go to the same co-extruded structures, but this time laminated with 12 micron PET. The graphs have the same setup, showing the seal force for formulations with the same percentage of plastomer in the sealant skin. Also on the laminated films, we see that Exact 3236 has similar heat seal force performance compared to the 902 density plastomer reference, and that Exact 3236 is better than the 908 density plastomer reference. Please note that we use the same percentage of blends in the sealant skin and not the same densities. So some might expect that for replacing a 902 density plastomer reference, you need a bit more of the 908 density plastomer reference, but that's not the case. We could replace a 60% plastomer of 902 density with Exact 3236, also 60%, and having the same seal behavior. The next slides will demonstrate that this is not only valid for seal performance, but also for HOTAC and industrial packaging line behavior. What you see on this graph is the HOTAC performance of the same co-extruded laminated films as the previous page. In contrast to the heat seal force, where the seal can cure for 2 days before the force is measured, the HOTAC force is measured immediately after the seal is being made. This situation is, for example, mimicking a vertical form fill and seal line, where the seal is made just before the product is dropped on top of it, so it has to be immediately strong enough to hold the product. On the x-axis, you see the seal bar temperature, and on the y-axis, the HOTAC force. We use the same colors as on the previous pages, so the Exact 3236 in the solid line, the dark blue, the C8 902 density reference in the dark gray dashed lines, and the other reference in the smaller dashed lines, and then the Exceed 1018 as a non-plastomer reference is the red curve. Exact 3236 has a broad HOTAC window, comparable to the HOTAC curves of the 902 density plastomer reference when using the same percentage of plastomer in the seal skin. And this was true for all different blend ratios that we tested. Previous data were generated in a controlled lab environment, as that allows us to test under standardized conditions, which are well recognizable in the industry. Everyone knows how to measure a HOTAC or a heat seal force. But we also wanted to get a feeling for the sealing behavior under realistic industrial conditions. So for this, we went to an equipment manufacturer of industrial packaging lines for a comparative study. Please note that these results should only be used as comparative fabrication data, as we could not control the whole setup, but it is a good indication of how this could perform on an HFFS line. HFFS stands for horizontal form fill and seal, which is, for example, used to pack cookie trays or wet wipes. Such lines operate at a very high speed, so it is a challenging test for sealing material as the sealing time is very short. The key takeaway from our trials was that Exact 3236 performed fluently on the different HFFS lines we used, and we could not see a difference between the Exact 3236 and the reference. To go more in detail, on the left graph are the results of an HFS rotary sealing packaging line, and the right graph is from a DCAM. I will explain more in detail. The rotary sealer allowed us to run the HFFS at a fixed speed of 20 meters per minute, which corresponds to 0.086 seconds seal time. To put that into perspective, the lab data we showed before were obtained at a standard seal time of 0.5 seconds. So the HFFS line is operating at 5 to 10 times shorter seal time than lab testing. At the HFFS line, the seal temperature was determined to obtain hermetic packs. An HFFS line has two separate sealing systems, one to make the longitudinal seal and one to make the vertical seal. So that is why we show both on the graph. comparing exact 3236 and the Plastomer reference in the same percentage in the sealing layer, the same temperature was required to get to that hermetic packs. This is valid for the pure Plastomer sealing layer, which are the two filled bars, which you can see at the left, so these two and these two. And it's also valid for the 30% Plastomer sealing layer, the stride bars, so these two and these two here. Exceed 1018, the red bars at the right, required a higher temperature, which is demonstrating also on industrial scale the advantage that Plastomers can have for high demanding sealing applications. On the right side of this chart, an HFFS decam sealer packaging line was run at a fixed seal temperature settings. The design of such a decam sealer allows for slightly longer seal times, which is also the reason why we could obtain running at a higher line speed than with the rotary equipment on the left. The maximum line speed was determined at which the materials could be run while still giving hermetic packs, so pushing the line to the extreme. Exact 3236 and the Plastomer reference gave similar maximum line speed, while for the non-Plastomer reference only a lower line speed could be obtained. So no worries if you do not remember all details on this slide. Our objective is that you remember industrial packaging trials on HFFS lines demonstrated excellent behavior of exact 3236 under very challenging short seal time conditions. The sealing data before were showing how exact 3236 has similar performance to the Plastomer reference. On top of that, the exact 3236 has a benefit in processability. We show that on this slide by means of the hot COF, or coefficient of friction, which is a measure for good processability when a film is in contact with hot surfaces. Some examples of such a situation is an HFFS line, where the film slides over a hot surface during the longitudinal sealing, or, for example, when doing a hot filling on a VFFS line. Note that in our experiments we did not perform hot filling in real life, but hot COF data can be used comparative and as an indication. Of course, testing and validation in your particular situation will be required, and we would be happy to assist you with if you need any help from us. On these graphs, a lower COF is better performance. For the measurement, a metal plate is heated with a test film on top of it. A metal sled will be pulled over the film. When there is so much friction that the sled is not staying in touch with the plane, this means the COF is not measurable anymore. And that's what you will also see on the graphs. When written not measurable, it means there was too much friction to really measure it. There are two charts giving different COF values. At the left, you see the static COF, which is the value at the instant that the motion starts between the surfaces, when the sled has to overcome that initial hurdle of starting to move, like when you would start with your bike at a red light. At the right, you see the kinetic COF, which is the value indicated after motion is already established between the surfaces. When you are moving, it's easier to keep on moving. So once you started biking, it's also easier to keep on biking. On the x-axis, you see the temperature of the metal. The dark blue bars are the exact 3236, and the lighter gray bars are the reference. We tested the co-extruded non-laminated films, of which you see the film formulation at the bottom left. In the film formulation, the same amount of slip and anti-block was added to the sealant skins. We used bare food grades of the exact 3236 and the Plastomer reference and additivated both exactly the same way, as that is very important in a COF measurement. There are two ways that you can see exact 3236 has a benefit over the reference. You always have a lower COF for exact 3236 compared to the reference, and as we marked on the graphs, lower means better performance. And a second way of seeing that improvement is The temperature at which a COF is not measurable anymore is higher for exact 3236 than for the reference. So on the left graph, for example, you can see that for the reference, the friction was too high as of 55 degrees C, while for exact 3236, this happened only 10 degrees later, so at 65 degrees C. Takeaway message is that exact 3236 has a benefit in processability when a film is in contact with hot surfaces, which is shown here by means of the hot coefficient of friction. We come then to the mechanical and the optical performance for the monolayer data. The dark line is the exact 3236, while the gray filled area is the reference. Performance is better when the value is more outwards of the spider chart. Exact 3236 has enhanced stiffness and toughness compared to the C8 Plastomer reference, which you can see by the improved MD tear at the top left, the 1% MD modulus at the top, and the dart impact at the bottom right. As these plastomers materials are often only used as a component of the C layer in a coex-extruded formulation, the stiffness and toughness enhancements will be less significant on a coex formulation, like we will show in a minute on the next slide. On the monolayer data, like we are showing here, the haze value is worse for exact 3236 than it is for the plastomer reference. But as you will also see on the next slide, when the plastomer is used in a coex-extruded formulation, this drawback disappears and the same optical performance is obtained. The setup of this graph is the same, so the dark line exact 3236 and the gray filled area is the reference, and the film formulations are given at the bottom right. We see, as I explained before, so the optical performance when we are comparing coex-extruded films with the plastomer only in the sealant skin, the optical performance is the same. And again, better performance is when the value is more outwards of the spider chart. If we look at the mechanical data, we see in general the values were up to 8% improved compared to the reference. So we can conclude in general that exact 3236 has similar to slightly better mechanical and optical performance than the plastomer reference. As a summary, this spider chart gives the main characteristics of exact 3236 with comparable sealing and packaging line behavior as a 902 density plastomer reference. All parameters are plotted in such a way that outwards is better. A big improvement that was not mentioned before in this presentation is the enhanced extrudability. You can see this at the bottom of the graph, where the melt pressure of the sealing layer is plotted with that inverse scale, so that higher pressure is in the middle of the chart and lower pressure, which is preferred, is outwards. The melt pressure went from 226 bars for the reference sealing layer to 190 bar for the sealing layer with pure exact 3236. On top of this enhanced extrudability, also improved stiffness and toughness was obtained. We explained before this was most significantly seen on monolayer films, but on this graph we plotted the coex-extruded films and you see it by the dart, the tear and the 1% MD modulus. And last but not least, we also highlighted enhanced processability on hot surfaces of packaging lines, like the static COF film to metal measured on the coex-extruded laminated films. To conclude on this slide, I want to mention, as was explained in the beginning, that exact 3237 is based on exact 3236, but including a slip and anti-block package. With this, I hand it over to Tom for finishing the presentation.
In conclusion, Mariana and I have walked you through what I would call the attribute profile of the exact 3236 and exact 3237. But I think the biggest insight is that everyone along the value chain can benefit from these resins. Converters will realize excellent processability and low melt pressures, which can be critical in thin sealant layers. and they should see a boost in the film stiffness and toughness. I believe that OEMs, original equipment manufacturers, will find that these films, made using these resins, will run incrementally better on their package making equipment. And likewise, integrated brand owners and co-packers should benefit from the stiffer, more forgiving hot coefficient of friction characteristics when packaging their goods on high-speed lines. And lastly, the hermeticity and high toughness of these resins, better dart, puncture, and tear relative to competitive premium plastomer offerings should help satisfy retailers and consumers when they receive fewer leakers or burst packaging on their store shelves or their front door. We sincerely hope that you have found this information helpful, and I encourage you to please contact us by any of the means that are listed on this slide. Thank you, and make it a great day.